Well, I've been posting quite a few Discus launch glider videos recently, and understandably so, you viewers have been asking that I please make a build tutorial describing my techniques in building these balsa wood Discus launch gliders. And I suppose considering how much interest I've taken in them and how many videos I've been making about them, it is high time that I made a proper tutorial. So this video will begin a tutorial series in which I'll go through the steps of building a simple 36-inch balsa wood Discus launch glider. The finished product will look something like the aircraft you see on screen now. Let's have a look at some flight footage. As you can see, it's a very nice flying aircraft. It's nice and slow, it thermals well, it turns tightly, launches to 20 or 30 meters pretty easily, and generally is a very nice handling aircraft. This video will begin the tutorial series by showing my methods of construction for the wings. Let's look at a list of the tools and materials you'll need. First, some medium viscosity CA glue and some accelerant, along with a dropper to apply the accelerant. A 12-inch ruler, a ballpoint pen for marking things out, and some sandpaper of various grits for sanding the airfoil. And lastly, of course, you'll need your X-Acto knife to cut things out. That about sums it up for tools. Let's now look at the build process. For the first step, you'll need nothing more than your ballpoint pen and your balsa wood. Let's get to work. We'll first be cutting the leading edge contour. As you can see, there's some damage on my balsa that I don't want to have in my final wing, so I'll make sure to cut my contour such that that material is removed. Furthermore, I'll make sure that the flatter of the two sides is the wing root. Here, as you can see, I'm using my ruler and my ballpoint pen to mark out the leading edge contour. This consists of two straight lines which angle progressively more steeply back from the wing root, and finally, a free-handed curve which sort of resembles an ellipse. Not super important what the exact shape is, just as long as it meets the edge of the wood rather nicely where the edge is tangent to the curve. Here, I'm using my X-Acto knife to cut out that contour that I've just drawn. As you can see, I'm using my ruler to cut the straight sections such that they're cut as straight as can be, and then I'm just freehanding the curved section. I'm doing this very slowly, mind you. The footage you see here is sped up numerous times, and it's important that you do this slowly because cutting this curve cleanly is very critical. Here, I'm using a sanding block with some 220 grit sandpaper to clean up that curve I've just cut. Now, it is still important that you cut the curve as cleanly as you can, because when you sand and clean up this curve, you don't want to be removing that much material. Our next step will be to trace that contour onto the other piece of balsa wood. Now, note here that because of the thickness of your pen line, the resultant shape will be a little larger than the wing you traced. That will result in this little inconsistency here where the line won't actually meet the corner. To combat this, make sure to put your knife blade a little behind the line when you go to cut out this shape. Here, I'll be doing just that. You'll see, once again, I'm taking my ruler and cutting this out, with the knife blade slightly behind, so as you see, it meets the corner nicely. Again, I'm freehanding this section and I'm taking my time to make sure I cut through it rather cleanly. As you can see though, I did mess up a little bit on the edge and there's a little bit of inconsistency. So as you'll see here, I'm quickly sanding that out. This next step is a very important one. We're going to line up both wings as best we can and check for any differences in shape. As you can see, my two wings are much more different than I would like, and so I'm going to have to use my sanding block quite a bit to sand off those differences. You really do want to avoid these differences as much as you can, because they'll result in you having to sand off much too much material, which will bring the wings farther and farther from the originally intended shape. We now embark upon the airfoil sanding, a crucial step to your aircraft's performance, so complete it meticulously and thoroughly. Begin by sanding the trailing edge, as I'm doing here. You'll sand it such that at the root of the wing, the trailing edge is 30% of the original 1/4 inch thickness. However, the trailing edge thickness should taper throughout the wing, such that by the tip of the wing, the trailing edge is very thin, perhaps as thin as a 32nd of an inch. You will now sand the wing span-wise, going root to tip. This will ensure that the airfoil maintains a constant proportion between its length and thickness throughout the wing. This is critical to the efficacy of your airfoil, so do it right and do it meticulously. We'll now sand the trailing edge taper into the bottom surface of the wing. Note that you'll have to match the root to tip taper that you sanded on the top of the wing. This can make things tricky, so work slowly and with minimal pressure to match that taper and make a nice thin trailing edge. Now, in the spirit of all this sanding we're doing, let's have a look at a little sanding technique. Allow the sanding block to rest in the first crease of your fingers. This will let your fingertips guide the sanding block and keep it flush with the trailing edge. Another good technique is to sand small circles along the wing surface. This will work out any bumps or blemishes that you put into the wing while doing your long straight passes. I have now sanded the trailing edge to a constant thickness of around 1/64 of an inch, but because of that span-wise taper I sanded, the actual high point of the airfoil maintains a constant distance between the leading and trailing edge. I'll now use the rounded edges on a stiff piece of 120 grit sandpaper to work out any little bumps or blemishes that the wing has accrued from all my sanding. We'll now check to see that those bumps and blemishes have successfully been removed, and after a few more passes with our 220 grit sanding block, we'll call the trailing edge done and move on to the leading edge. Actually, wait, before I move on, let's just take a look at my work here. This trailing edge taper came out really nicely, and you should refer to it when sanding your own wings. Alright, now it's time to sand that leading edge. We're going to maintain a constant angle between the balsa wood and the sanding block such that we sand a flat taper on that top surface. This comes from Stan Buddenbaum's stand foil. He's shown that gliders with this airfoil perform noticeably better. In my experience, there's actually no noticeable difference, but since he says it's good and he knows what he's talking about, I figured I may as well do it. Next, we're going to sand the bottom surface of the leading edge. Now, this will simply be a normal curved leading edge. We're just going to curve it off by using a sanding block and sanding at various angles to produce something of a curve. Now, as you can see, this step has been thoroughly completed, and that means we're so close to being done with the airfoiling process. But there is one point I want to make very clear, and that is the rounding of the tip. Alright, I do apologize for being a little out of frame here, but I think you'll get the idea, and that is simply that, in my experience, rounding off the aircraft's wingtips can have a noticeable improvement upon the flight performance, and it's a simple thing to do, so round the wingtip. In this next step, we're going to use a very fine grit sandpaper to smoothen down the wing. In this case, I'm using 500 grit, but I've found 720 and even 1000 grits will do a similar job, so long as you have the patience to sit there and sand for half an hour or so. In this case, using a 500 grit sandpaper, smoothing down the wing only took me 5 or 10 minutes. It's a very simple step, but it lowers the skin drag of the wing and is pretty important if you want to maximize the launch height of your aircraft. As you can see, we now have a completely finished wing. It's smooth, it has a nice airfoil, it's tapered properly, the tip is rounded, and the weight is very low at just 11.5 grams. But you see, here's where things start to get tedious. Because you know all that work you've just done? Yeah, you gotta do it all over again on the other wing. Alright, both wings have been finished now, so we ought to be able to move on to the next step. But before we do that, let's have a look at the finished products. As you can see, the two airfoils I've sanded are very close mirror images of one another. However, on this wing I sanded the trailing edge slightly too thin at the wing root, which is something you want to avoid because if anything, the root should be the thickest and strongest part of the wing. We'll now measure and cut a 6 1/4 inch dihedral jig from a piece of scrap balsa. Setting this piece of wood under one wingtip when we adhere the wings together should give us the 10 degrees of dihedral per wing, or 20 degrees in total, that we're looking for. We'll now use our 220 grit sanding block to sand an angle into the wing roots, such that when glued together, the two wing roots will meet flush at the desired dihedral angle. Here you can see exactly what kind of angle I'm talking about. We'll check once more that the two wings meet at the proper dihedral angle, and then we'll move on to gluing. Here you can see I've got my Loctite CA glue, and I'm going to put down a paper towel to make sure I get no glue on the table. I'll then carefully apply glue to the wing root, and I'll stick the two wings together using that 6 1/4 inch jig to make sure I get the proper 20 degrees of dihedral angle. I'll then take my Bob Smith Industries accelerant and use it to strengthen up that wing joint. It's now time to take that 220 grit sanding block and smoothen off and flatten out the wing join. Here I'm showing how I've also slightly rounded off the tips, which in my experience can increase aerodynamic efficiency in certain cases. And after that, we can pretty clearly see that we have ourselves a finished wing. And with that, we conclude the first episode in this tutorial series. I hope you've enjoyed watching and have learned a thing or two, just as I've enjoyed building and hope to have taught you something. Stay tuned for the next episode, in which we'll go over how to build the fuselage and install the electronics. And as always, thanks for watching!